the record. بسم الله والصلاة والسلام على رسول الله صلى الله عليه وسلم. Welcome to the statics GE201. So this is the week number 3 of fall 2021, and this is our second meeting with section MA2, which is on Thursday. Okay, is it related to the course حازم؟ يتعلق في المادة أو خارج المادة؟ Quickly, if it related to the course, say it now. If it doesn't relate to the course, keep it at the end. تفضل. Do you have microphone?
السلام عليكم ورحمة الله وبركاته.
I cannot hear you guys. يعني your voice is really low. I cannot hear you. Increase your voice, guys.
الصوت واضح دكتور؟ عندي بس مداخلة سريعة. واضح الصوت يا دكتور؟
I have a problem. So let me get out and come back again. Assalamu alaikum. Okay, can you hear me now, guys? Hello? Guys, can you hear me? كان anyone يعني عبد الرحمن الشرفة موجود؟ تكلم بالله يا عبد الرحمن. Let me see. Can I hear you clearly or not? Guys, can you hear me? Hello?
Yes, Doctor, we are. Can you hear you?
ايوه يا دكتور نسمعك.
I can't hear you guys.
نسمعك يا دكتور.
Hello?
نسمعك يا دكتور نسمعك.
Guys, can you hear me? Hello? Hello? Okay, can you speak? Use your microphone. Let me see if I can hear you.
هاي دكتور تسمعنا؟ دكتور تسمعنا ولا؟
Unfortunately, guys, I cannot hear you. Don't know why. So there is a problem. There is a problem, شباب. يعني you can get out and log in again. Yeah, I think there is a problem. Anyway, because okay, let's start the topic. So so this is our second meeting of week 3, where we already finished the force system in 2D. So today we are going to explore the force system in a 3-dimensional scenario. The 3-dimensional is basically nothing than you have the third dimension in Z direction. And so as you know that we have the Z direction, and if you follow the right hand rule, this would be Y axis and this is X axis. Okay, so we only add the third dimension, and by adding a third dimension, so the problem in statics becomes a bit complex, where you need to now imagine the force and get the components in the third dimension in the Z axis. Guys, can you hear me clearly? Because I'm explaining right now. Can you hear me? If you hear me, raise up your hand. Okay, that's good. That's good. So I will keep explaining, and then we try to fix the problem of your microphone later on. I mean, focus on the today's lecture. Okay, so basically adding, as I mentioned, adding the third dimension, now the problem becomes a bit complex, where we need to imagine and try to find the third component, for example, of the force, which is a force vector. Okay, So at the end of this lecture, we need to know how to resolve the force into 3 rectangular components and how to describe the direction of a force in the 3D space. And we need to learn about the dot product in case of 3-dimensional and the importance of that. And then we need to do the moment and couple in 3-dimensional scenario, where we'll know about the cross product, and finally the resultants in the 3-dimensional space. So basically, you remember that to do the rectangular component in a 2D, we were only writing that the one for the X component and one for Y component. This is for the 2D. And then adding this one. So now this is the third component in the third dimension. Okay. So this is only adding this one. So the fx so the component, for example, the picture that you see in the right hand side, we can write the component of that one along the x, y, and z axes, right? Where you notice that the component along along x and y and x axis is the magnitude time the cosine the angle. For example, theta x along the x axis, theta y along the y axis, and theta z along the axis, like from the main force vector. Okay, so this is the main force vector. Okay, vector F in a 3D space. Simple, right? يعني near to the near to the theta, it is cosine. Simple, you know that. So this is along x-axis. We can write F with the unit vector I, as you can see here, right? And if you use also the cosine's direction, you can write it also in L, M, and N, as we learned in the 2D. But what we need to do now, instead of LM, we add one more N for the z-axis, and the unit vector in the z-axis is K, letter K, small letter K. That's it. Okay, and this is the resultant, which is just only the summation of the vector, sorry, the component of this, the main vector along the 3 axes. Simple, right? So simple is nothing new, only adding the third dimension. And here is one more explanation to write in. So we know that how you write it in terms of also cosine vector. Okay. And in solving the 3-dimensional problems, one must usually find the XYZ scalar components of a force, as we saw in the previous slide. And in most cases, the direction of a force is described by 2 points on the line of action of the force, or by 2 angles which orient the line of action. So this is really important. Pay attention for this, and more explanation in the following slides. First, so specification by 2 points on the line of action of the force. So what we need to do, so we need to specify by using the 2 points on the line of action. So if this is the force, if I line of action, as I told you, so is along the force direction, right? So I can specify one is here in the space and the second point, so A and B, right? And then I can define that in the space using this algebraic equation or geometric equation where f, it is nothing than the magnitude times the unit vector, and in here in the space the unit vector, it is the, I can take the length of A divided by the vector A divided by its magnitude, the length AB. And you know that I can find the vector in terms of a components in I and G and K, and I can find the magnitude by the resultant force, which is the summation of the length of this magnitude squared of this under square root. You know that this is the resultant, right? So guys, you remember that any unit vector is nothing than the, for example, it says r divided by the magnitude or the resultant. So this is the resultant. This is magnitude, so in I, J, K. This is in 3-dimensional. In 2-dimensional, just I and J, which means just X and Y. In the 3-dimensional, X, Y, and Z. Okay, and the magnitude is nothing that is the resultant, which is square root of the square summation of the magnitude of the vectors along these axes. Clear, guys? So far, and so far, if it's clear, raise up your hand, because the microphone is not working with you. I don't know why. If it's clear, raise up your hand to follow. Keep continuing. That's good. That's good. So now define or specify by using two angles. Basically, this is simple. This is also another way to resolve f into horizontal and vertical component using the right angle triangle or the rectangular component in 2D, where I need to find the location, for example, of f. In here, in this case, it is in this direction. It makes a theta with the x-axis and make phi along the plane of xy. Again, I repeat this again. This axis f, it is on the plane. I can see here it is x along z axis, right? This plane. So let me change the color. So this plane, and if you notice that the angle also, it makes another angle with this plane, right? So this plane with the purple color, it is an xy plane, xy, it is the projection of f along the xy plane, right? So to resolve into horizontal and vertical component, fxy plane, it is nothing than, as if you are saying it is f times the cosine theta, cosine phi, okay? And fz along the z axis, it is f sine theta. So it means that we find the component. So let me change the color. So one component of this f, one along z axis and one along the plane of, okay, of xy plane, and define that projection. So with the theta that is corresponding to x-axis, or you can assume this one would be a cosine, because this one, it is also this one, which is also equal to this one. And phi angle. So all of this with the phi angle. Okay. So now continue, resolve the horizontal component fxy into x and y direction, or plane in specific. So become now fx, it is fxy cosine theta, so this is along the theta, which is fx phi times cosine theta, and the fy along the y-axis, it is fx sine theta, which is f cosine phi times sine theta. So if you look to the picture, you're gonna know how to do the component. If you are good in doing the component in the 2D, it's easy, you can understand this. So do not confuse, guys. Okay, so it's simple. Just follow these equations and see how they are distributed or lay out in the axes. So important note, we must use the right-handed set of axes in our three-dimensional works. So we know, as I mentioned, so use the hand rule, right, which says that from x axis to y axis, if you use your hand right, if you use your right hand, you will get this axis, this direction, the upward direction. Okay, so from x to y, this will give, if you use your hand, the fingers, it is the, if you curling your fingers, this is the direction from x to y, and then the thumb, it is the directing to the upward, to the z direction. Clear? So now, how to describe the direction of a force in a 3D space? So we use something called dot or scalar product to define the direction of a force in a 3D dimension, where the dot product, it is nothing than the magnitude of B times of the B and Q. It is B times Q times the cosine alpha between them, as you can see here in this picture. Okay, so this is X and B, and this is the alpha. So this means that the dot product is the projection of a vector on another vector. Okay, so the dot product of any two vectors B and Q is a scalar quantity. So now the fx, it is f cosine theta sub x, so along x-axis, and fy, it is f cosine, as we explained on the first slide. Okay, or we can say this is with a unit vector, so fi, f dot product j, and f dot product k. Okay, so unit vector. And a more explanation, so fn, the unit vector, is a unit vector in a specified direction. The projection of f in the n direction has the magnitude f sub n, right, which is nothing than the vector times the unit vector n, and the vector quantity, it is nothing than saying that you have dot product of f, the force vector f, times the unit vector n, and then within parentheses times the n vector, which means f dot nn. What does that mean? So if this is a direction in cosines, we mean that the unit vector is alpha times the I and beta and gamma, j and k respectively, right? And in terms of cosine, you can say lmn, right? If you remember that, guys, in dot product, we used to say that if it is I dot I or j dot j or k dot k, this will give us a unit, right? Because it's a unit vector. 1 times 1 is 1. But if it is you dot product the I with, for example, with the one it is perpendicular, for example, j, so this is the unit, the angle between is 90, and cosine 90 is 0. Okay, so you know that. You know, just to remind you, for example, if I have b dot product q, it is nothing than the magnitude cosine alpha, which is the angle between them, this alpha. Clear, guys? So you know cosine 90 is 0. Okay, so angle between the two vectors, as I mentioned, if you want to know the angle, so it's nothing than the cosine inverse the b dot q divide the which is the vector, divide by the resultant, right, which is, this is a unit vector. Remember, this is nothing than a unit vector. This is, let's say, the general unit vector n. We have explained that just a while. But in this time, sorry, this is not a unit vector because this is a dot product, and this is a dot product. No, it's not. It's not a vector. Okay, sorry guys. No. So this is cosine inverse of this equation. Okay, which is the p dot q, the vectors, right, divided by the magnitude. Okay. Okay, so let's see one example that is in your book to understand how to implement and how to find the components along this 3D space. So the questions, guys, are you with me? Hello? Can you hear me, guys? Okay, that's good. So a force F with a magnitude of 100 Newton is applied at origin O of the axes X, Y, Z as shown. So this time, this is axis, X axis, and this is Y, and here is Z. Okay, so the line of action of F passes through at a point A whose coordinates are 3 meter, 4 meter, and 5 meter. This one. And then determine the X, Y, and Z scalar components of F and the projection Fxy of F on the XY plane. Okay? And third requirements, the projection of FOB of F along the line OB. So find the first one. Guys, get a pen and paper. Try to practice with me. Okay, find the first one. Find the X, Y, and Z scalar components along of F. Simple. This is straightforward of applying the equation. Find it. Quickly, this is an example in your book. Try paper and pen and try to practice what you learned in the previous slides and see the level of your understanding. So he asks you to find the vector, the scalar component XYZ of this vector F of 100 Newton, right? Simple. Find the component. Okay. So what we need to do, we ask you to find. So before I show the solution, I want you to think about it. So he asks you to find the component of this Z along X-axis, Y-axis, and Z-axis. Okay, so this one. Think about it. Give yourself a chance. And read the question. It tells you like this: we have a line of action point from O to A. It makes a coordinates of 3 in x-axis. Read here. So 3 meter in x-axis. So that means this one, the magnitude along x-axis, right? And 4 meter along y-axis. 4 meter along y-axis and 5 meter along z-axis. So now we have the magnitude, which is here, right? So here it's 3 meter. So it means this one along x-axis, the component, and here is a 5 meter, and here is the y-axis, 4 meter. So what does that mean? So you have different ways, right? The book gave you a way to find this one, and you might solve it with your own way if you can't find, for example, the angle. يعني you remember that we mentioned we have two different way, right? Either by the two angles or by knowing the 2 points along the line. So this we know we gave us the point, so we need to use this equation, right? So he gave point A, so we know the point O to A, so we can use this one and find the answer. And then by finding the answer, you get the result, and then I can find I, J, K. I can know the f-axis, this one f along x-axis, and this is the scalar component along the y-axis, and here is the scalar component along the z-axis. Simple, right? Clear, guys? So here is the answer. Have you tried it, guys? Have you reached to any solution? It's this one. So he used that equation because we know he gave us the point along the line of action of this force, and so from O to A. So I can use this one, this equation. So I know the unit, I know the magnitude of F, right? Which is 100 Newton. And then the O to A, what is this? O to A, he gave us the magnitude along the 3 axis, the 3 along x-axis, so 3 multiply the unit vector, 3i, plus 4 along y-axis, 4j, plus f along the z-axis is 5k. This one, OH, it is the resultant of this, the magnitude squared under square root. That's it. After you find this, you do the calculation in the calculator, and then you find this one, and this one, and this one. So we have three values multiplied by 3 unit vectors, I, J, K. I, it is for f-axis, magnitude of this one corresponding to the x-axis, and this is for the y, and this is for the z. Clear, guys? I hope this point is clear. Second requirements, so back to the question, it asks you to find the projection of f x y of f along the xy plane. So this is the plane that is talking about. So we need to define the plane. So this is the plane. Here, ask you this one. So here it is xy plane. Okay. Clear? Ask you to find the projection. So along this plane, how can you find it? So we know we do need to use the advantage of dot product, right? Where we can know the cosine angle between the two vectors, for example, which in this case, cosine theta, remember here, so cosine theta, you can find from here. Cosine theta is the vector b times the vector q divided by pq. So what does that mean? So if you look to the answer, so we solve first of all, tell the fxy is equal f cosine theta. So I need to find first of all f cosine theta. So I find that right? F cosine theta, which is along this one. So F cosine y, F cosine theta. So it is the square root of 3 plus 4 squared divided the square root of the, if you locate this on the figure, right? So now F cosine, so plug back cosine theta xy, so this will give us the projection of fx of f along xy plane, which is f sub xy, and the magnitude. Okay, think about it. Think about it. This is an example. It is explained. It is well explained on the book. Part C. Again to the question. He asked you to find the projection FOB. This one. This is O. This is B. Along F. Of F along line OB. Yani he wants the projection of this one along this one. Yani we need to find the theta again. The unit vector first between them. So you find the first, the unit vector NOB, which is the magnitude, so it's the vector OB divided the magnitude, right? And then we need to find the scalar projection of F on OB. After that, you can write that in terms of vector notation. Simple. Guys, it might be, you find it difficult, but sit down and try to look to the problem and get the pen and paper. I told you, you have to keep pen and paper right next to you, right? You have to draw and see and figure out the values, القيم على الاكس y, and try to find the unit vector and all of that. Just an implementation, right? And see the example in the book, and also it gives you اختصارات كثيره شباب، ما يعطيك الحل كامل، فتحتاج انت انك تطلع كيف تطلع الفاليو هذه، فين القيم. واضح يا شباب؟ لازم تستخدم ورقه وقلم براكتس. تمام؟ واضح يا شباب؟ get back to the book, you find this an example in the book and read it and try to understand it. Okay, so now let's go to next topic, which is a moment in 3 dimensions, right? So simple, exactly as in 2 dimension. We said that we need that the distances should be perpendicular to the vector force or force vector, right? That will give us a moment. If you use the right hand rule, the thumb will point to the direction of that moment, right? And the coral أصابع البقية fingers, it gives us the direction of the moment, right? So the moment due to F along the point O, it is the rotational around this axis. Okay, simple, which is also here we said is a cross product, because the first cross product of 2 vectors, it gives us the vector, right? So the cross product is give us the vector. It means the third vector here, right? We said that R cross F is equal this one. So R times the sine angle between, which is alpha, between the 2 F and R here. Can you see this one? So F cross product R, right? It gives us the in vector m, a moment vector, right? Which is equal fd, which is the magnitude, right? So in terms of cross product, if you cross product two vectors, it gives us a vector, which is here in this case a moment vector. And then if you analyze it or do it algebraically, you know that the cross product of two vectors, it is nothing than the magnitude of two vectors times the sine angle between them, which is f times d, which is the magnitude. Give us the magnitude of the moment. Okay, so this is one of the advantages of the cross product. Look at clearly here, guys. You know that the angle, the distance should be perpendicular, as I mentioned, to the line of action of this vector. This is one of the important, they call it feature. يعني to make a moment, so we have to have the perpendicular distance from the O. So moment around O, we have to define the perpendicular distance along the line of action of that vector. Clear? I hope this is clear, guys. And you know that the cross product is not يعني العمليه ليست ابداليه. لما نقول R cross product F is not equal F cross product R. This one is M, the other one will be in other direction, like this. Okay? So negative sign, it means it will be in other direction and rotate in opposite direction. Clear? And let me highlight this again. يعني most of the time people define that the moment counterclockwise عكس عقارب الساعة is positive and the opposite is negative counterclockwise مع عقارب الساعة. لكن sometimes you find some books they write it like this oppositely. They said like this is positive. So you have to be consistent, guys. If in your calculations you assume your sign convention as this, so you have to stick this through all of your calculations. If you assume this way, you have to assume through all your calculations. Clear, guys? If it's clear, raise up your hand. So I will not repeat this again and again. So you have to be consistent. يعني خليك ملائم ومتناسق في فرضياتك للاتجاهات. اذا فرضت انه يمين شمال اعلى هذه كلها بوزيتيف الاكس واي زي، خليك ماشي بهذا الفرضيه. اذا فرضت انه لفه الدوران معاكس عقارب الساعه هي الموجب، خليك ماشي هذه الفرضيه. واضح؟ يعني في كامل حلك للمساله، مو تجي تغير مره تحط كلوك وايس بوزيتيف مره كنت كلوك وايس بوزيتيف، حيصير عندك غلط، فيكون عندك غلط في الاشارات، يصير بدل ما تجمع تطرح او العكس، فهذا مشكله يعمل لك يعني في السميشن ليتر اون في الاكوليبريم. لو هناخذ الشابتر القادم هيعمل لك مشكله، ما حيكون عندك بالانس في السيستم. واضح؟ طيب here more explanation of what does cross product means. Okay, so we will يعني could be explaining by the two fingers and one thumb, where one finger for B and one finger for A vectors, and then the resultant of this cross product along the thumb. So it's similar to the right hand rule, right? So as you explained here, one through the positive, one through the negative. So it depends on either A cross B or B cross A. Okay? Here is the more explanation for cross product, where we can find the determinant, right? So I, J, K, if I have R, X, R, Y, R, Z, which is the unit vector, which is the magnitude along this unit vector, and this Fx, Fy, Fz, right? If you open this determinant, you're gonna find this. Just remember, I just cited to you here. Remember that how you find the cross product and for the determinant, just for you, right? And you will reach to this one, Mx, My, Mz. So this is the scalar of M along X and along Y along Z. Okay. And if you look to this explanation, it explains to you يعني الفيجر, this figure, if you want to know the rotation along the z axis, along the x, y and z axis for this vector, for example f, right? All what you need to do, you need to find the components f, x, y, and maybe then you find the perpendicular distance from along this one through all of these axes, right? Or right away using the cross product, right, guys? So this is one method using the cross product. R, it has Rx, Ry, Iz, and then F, it is have Fx, Fy, Fz. If you do the cross product, which is using the determinant, you will reach to this one, and then this is what does it mean. Clear? This is one way. Okay. So this is the beauty of statics. You have different ways to find the answers. Here another way, or here more explanation, I mean, for the cross product, where you know this is sine alpha. So if you have a cross product, it is the sine alpha. Sine alpha, where the sine 90 in this time equal 1, right? So I cross j, which is 90 degree between them, so is equal k. What does that mean? So the two product of the two, it gives us the vector along the k and the vice versa. Okay. So j cross k, it gives us along the unit vector of the third direction, and so on. K cross I given j, j cross I, which is an opposite, so negative, and j cross is negative I, and I cross k is negative j. And if you cross the product I cross I, cosine zero, cosine 1, sorry, sine 1, sorry, sine 0 is 0, okay? And sine 90 is, sorry, sine 90 is 1, okay? You know this is from unit circle. They call it unit circle. If you do not remember it, let me upload. This will remind you. So let me upload the remind you with this. Yes, this one. And then we'll get back to the slide 17. Guys, I think you still remember this one, right? From the mathematics, the unit circle, right? So cosine 0 is 1, but sine 0 is 0. Here, cosine 90 is cosine 90 is 0 and sine 90 is 1. Clear? شباب واضح؟ This is a unit circle. Or use a calculator and you can find the answer. So let's go back to page 17. Okay. And if you follow and lay out the cross product, you find this one. Okay. Okay. So here is also more explanation where something called triple circular product. So we have cross product dot another vector. So cross product of two vectors dot to product a third vector. So P, Q, R. So I have three vectors, right? So what does that mean? So this is equal also if you عملية بدالية. If you say 3 dot B cross product the other two vector. يعني either in the beginning or after. Okay. Okay, the dot and cross may be interchanged as long as the order of vector is maintained. So B cross product Q dot R is equal to B dot Q time cross product R. So guys, do not confuse. This is not like a multiplication. This is dot and cross. Dot is a scalar product and cross is a vector product. Okay, so you have to understand that. So we do need to use this in terms of Cartesian and coordinates and find the vectors. So it's really important. And you have studied that actually in physics and math. Determinate, as we said that in previous slide. Okay. The triple vector product. So we have now 3 vectors and cross products them. And here is the conditions. Okay. Here the parentheses must be used. Okay. Because the cross product is give us a vector. So it means that either positive or negative. So we have to be careful about the parentheses. Clear? Guys, are you with me, guys? Hello? Okay. Okay, let me continue if you do not have questions. So this is a moment about an arbitrary axis. Okay. Now we have arbitrary axis. So we want to find the moment around any arbitrary axis. Let's say here the axis that I want to find which is lambda. So lambda axis. Okay. So just simply is R cross product F dot N parentheses times N. Or simply use this determinant and find the determinant. Okay. Just for your information. Okay. If you want to find the moment of F around any arbitrary, so first of all, you need to find the projection of MO around that, which is M sub Y, which should be have like perpendicular, right? As you can notice here. And then you have R, right? So simply, so find the component of this one, which corresponding to the original one, right? So M sub O dot the dot product is a scalar. This is give us now a scalar, and then to obtain the vector of this one of F about Y. So simply, it is a directional unit F to the multiply by this magnitude by the unit vector, N vector I mean. Okay, so that means it is the magnitude times N or M dot NN. Okay. We know that MO, it is R cross F, right? And then just put N dot N, and then between parentheses, the N, this N comes from. So one N to here, you know that M O dot N, right? So this one from here. Clear? Okay. Here, the Freygunus theorem, you remember that we took it in 2-dimensional, exactly the same in 3-dimensional. It says that the components of any vectors, it had the same effect, equal the same effect of the original vector. Simply like this. Okay? يعني in simple words. يعني الدوران اللي يعمله الفيكتور الرئيسي هو نفس الدوران اللي يعمله كل components of هذا الفيكتور حوالين الاو. simple. خلاص؟ يعني بكل بساطه يعني حتى do not confuse. اوكي؟ وهذا شيء منطقي يعني. شيء منطقي لانه components يعني هي belongs to the original vector. واضح صح؟ طيب الان الكابلز قلنا this is a sort of a moments يعني نوع اخر من المومنتس الدوران عزم الدوران او they call it torque ولكن بسبب ايش؟ it's not يعني only one vector اللي هو force vector but now we have two equal and opposite in direct vectors one F one minus F and then between them it's a distance d, and due to that this will cause us a moment. تمام؟ يعني انا اعطيكم مثال يعني واقعي للمثال هذا. الا تفتكرون مثلا السياره، كفر السياره مثلا عندنا بولت، تمام؟ في عندك اما تستخدم مثلا tools can use it by one hand and push the force here to open, right? And maybe you have another tools that it is, for example, a T, they call it a T tools, right? And then use one force like this and then the other force like this to generate a moment. Clear guys? Clear? واضح يا شباب؟ This is one application of the moment. يعني يكون angle هنا الانجل بينهم يعني 90 degree حتى تصدر المومنت حوالين البومنت وتقدر تفك مثلا البولتس. هنا نفس الشيء ممكن تستخدم اللي هو التي tools where you push one force like this and the other force in opposite direction, and then you can generate a moment. Here we will be generating a moment. Clear guys? or torque. واضح يا شباب؟ So the moment يعني couple is sort of a moment, so it applies all يعني the يعني exactly same as a moment. So R cross F, right? This is the vector, and then you can find the magnitude, which is F times D. Here is more explanation where the moment of a couple is a free vector. So we have a free vector, right? Whereas the moment of a force about a point is a sliding vector, whose direction is along axis through the point. So we have to get back and review. I explained it in like details, the difference between free vector, sliding vector, and fixed vector. So you have to get back and understand what I explained previously. Okay. Here it is the couples. Again, the last point about the couples, and then we go to the example. Right. So it says that in 3-dimension, right, in 3-dimensional force system, we can replace a force by its equivalent force couple system. So if I have F, so along point A, I can find the opposite along B, which is minus F, and then to make this in balance, so I need to draw also F along B. So it means now this is cancel each other, right, guys? So here F, which is equal to this one, because this one F, so let me use the pen. This F along this point, F cancel this minus F, right? So equal and opposite direction along the same points. Okay, so since we have the distance between A and B, so this F within the opposite direction minus F along B, this will cause us a couple, right? This is couple where it causes a moment along the B axis, B point, for example. Okay, simple, right? So this is an equivalent, يعني مماثل مقارب. اوكي، ممكن امثل انا القوه، يقول لك ممكن تمثيل بايكويفالنت فورس couple system. تمام؟ يعني as we did in a 2-dimensional, if you still remember. See, this is also an يعني example explains and give you a hint how you can solve and find the couples and moment. For example, it says determine the moment of F about original point O, where he wants first inspected by inspection and B by formal cross product. Right? So use the formal cross product and by inspection. By inspection, you have to look to the figure. Right? So this F, where it's located along the y-axis. Right? It is the XY plane. So this rectangular box, it has A, B, C dimensions. So simple. So find the component of F and then multiply it by the perpendicular distance from O. this is by inspection يعني graphically يعني من الصورة من الرسمة صح يعني تطلع الكومبوننت هنا والونج الزي اكس الواي اكسس فعندنا minus c f along the I direction which is x direction this is I c لانه عندنا البربنديكولار المسافه ما بين اللوكيشن حق الفيكتور هذا f مع الاو يعملها المسافه هذه الدي سي واليونت فيكتور يعطيك اللي هو الكومبوننت تبع الاف على الاكس اكسس واضح again along y عندنا الدايركشن حقها هكذا البربنديكولار it is a but pay an attention a but is عندنا ايش معلش along معلش شباب along الواي عندنا بنفس ايش الاتجاه اللي هو البي اذا يبقى بنفس الاتجاه معناته عندنا زيرو along الواي زيرو along الزي يعمل دوران بهذا الاتجاه multiply by a واضح يا شباب واضح واضح ارفع يدك يا شباب easy الان cross product just يعني apply the equation cross product is so simple right so the r you can find the r and f it is the unit vector of f right so ai plus ck right and then cross the product of f j so simply if you look to the figure and try to use the cross product right so from o to r this is r right so this means it has two components one along x-axis and one along y-axis this is for r for f it has one component along y right so it is along y so just cross the product this easy right so you know how to do a cross the product so afk because aj a cross product j we said this one give us k this one ck times fj so c it is this one and then k cross product j guys just remember this I j k if you go like this one give you positive if you go يعني I cross j it give you positive k j cross product so this is positive if you go within the direction يعني مع قارب الساعة يعطيك الحل الثالث العكس صحيح فيصير j cross product I cross product j يعطينا k j cross product k يعطينا I اعكس إذا عكست عشان يريمبر it k cross product j زي ما عندنا المسألة هنا ايش يعطينا negative I which is this one clear guys واضح معلش Hello. Okay, can you hear me, guys? Clear? Raise up your hand. Okay, that's good. Okay, here's an example. I will leave it to you. This is an example. I'll leave it to you. Read it. It's really important. Read it in the weekend. It is now for you. The solution is there. Read it. Try to understand it. It's well detailed solution. Okay? Because we don't have much time to discuss it in details. Finally, resultant, as we did in 2D. Just here we have one more dimension. Simple is exactly the same. And the moment, you can find the moment. It's simple. Simple, guys. Just to add one more direction. So I don't want to spend that much time explaining it. And resultant is just, I mean, components along all the axes. Okay, and then we have concurrent force. So all of them in one point is called concurrent. And then we have a parallel force. This is parallel, you know that, right? So, and then we have coplanar, so in the same plane, coplanar forces. I explained that in the beginning of the, I think, second lecture or something like that. Okay, and then with the wrench resultant, it's when the resultant couple vector M is parallel to the resultant force R. So the resultant is called a wrench resultant. Okay, wrench يعني انه عندك resultant force due to any forces. تمام، يعني كانك يسموها رينش لانه كانك مثلا عندك اللي هو التولز المفك مثلا وبتفك المفك، انت بتحط مومنت وبنفس الوقت بتضغط فورس. يعني اذا كان عندك هذا سكرو يعني تبغى تحطه مثلا في any tools, you have a tools and then you do a moment, apply a moment, and at the same time the resultant force of that one will goes inside that part. This is why they call it wrench resultant, and it's explaining here. So I'm doing the moment, right, and the resultant in this direction, or I'm doing the opposite, right, and still the resultant in the other direction. So opening and losing, right? So as if something similar to the wrench. Okay. Here's more explanation also for the 3-dimension for resultant, where it says any general force system may be represented by a wrench applying along the unique line of action. Okay, we see from figure that axis of wrench resultant lies in a plane through O, normal to the place defined by R and M. So the wrench is the simplest form in which the resultant of a general force system may be expressed. Okay, so this form of the resultant, however, has limited application. Okay, so here is different problem or examples for defining the resultant in a 3D. And then inshallah next week we're gonna solve a couple of problems. Here is just a simple, straightforward problem, right, to finding the resultant. It's so simple, right? So it gives you here the forces applying in this part. It says determine the resultant of a system of parallel forces which act on the plate. Solve with a vector approach. So simple. So you have here a parallel forces. He asks you to find the resultant force. So simple. I'll leave it to you guys. It's so super simple. And next week, inshallah, we're gonna solve a couple of problems. Okay? Inshallah. Any questions, guys? Just go home, look at these examples, and next week, inshallah, we'll show you a couple of problems. Also, we'll give you a couple of problems to solve at home, practice at home, and inshallah, everything is easy. Just in 3D, the only difficulties you guys are gonna find it is how to imagine and how you analyze this carefully. Okay, so because adding one more dimension, it's making the problem a bit complex. So we need to be careful and try to understand the dot product, cross product, and practice these things and be professional in this. خليك عندك مهنيه يعني مرن نفسك، ابدا حل اكثر من مساله حتى تكون متمرس في استخدام الدوت برودكت، كروس برودكت، يعني تحليل الكومبوننت على 3 دايمنشن. بهذه الطريقه يعني كل ما تمرست اكثر كل ما كانت عندك الصوره اوضح. تمام؟ Any questions guys? So we have only one student absent. Who is that student? Please stay guys, let me see. So Mazen Agleti is here. Who left? Is reconnecting now. Okay, so we have 9 students. So here's 1 student is absent. Who is that? Is here Rayyan? Saud is here. Guys, I don't know if you remember that. Rayyan, yeah. So Rayyan is here. Hazim is here. Rahman Hijayat, Rahman Sharfa, Abdurrahman is here. Abdullah Bagroon, Abdullah Mugawi here. Umar. So the absent is Umar, right? Umar Al-Juhani. Okay. Okay, guys. I'm gonna take the attendance from the blackboard. No worries. Maybe you have noticed that I sent you back the correction of the first quiz. Okay. If in the email. So prepare yourself. Maybe also we'll have a quiz right after we explain the problems, or maybe I'll give you right away next week. Just prepare yourself for this resultant topics for 3D dimensional, I mean. So prepare yourself, okay? Maybe next week or the week after. Most likely the week after, so we'll be in week 5th. Okay, but practice whatever in the example here, okay? Any questions, guys? Guys, any questions? Hello, can you hear me, guys? Hello? Okay, that's good. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت أستغفرك وأتوب إليك. Okay, guys, see you next week, inshallah.